Welcome to this session, and in this session let us discuss about the listener interface. Fine. And now what is the listener interface? Now just think, whenever we are talking about the event handling in Java, it is going to follow a delegation event model, and which majorly contains two parts. The one part which is going to be the user interface where the user can interact, and the other part which is going to process whatever the input the user is going to give will be processed. And that is what we call delegation event model contains the two parts. One part, whatever the classes we have seen in the previous session, that is going to be the first part, and the second part, whatever the listeners we are going to discuss in this session, that's going to be the second part. And now when I go and talk about the sources, now it's going to be about the event classes, what I presented to in the previous session, and the few event sources which will be used whenever we talk about the event classes, or for every source there is going to be event classes. For example, we are going to have this following event sources from where we can generate the event and we can make use of these objects, and whenever there is an input from any of this event source, an object for this particular event along with the event classes will be created and will pass on to the listener. And so once we are going to have the event at the listener is going to make use of the interfaces, or we can say the source is all about the event classes and listeners is all about the event interfaces, which is stored in the header file or in the package java.awt.event. And so now when I am going to talk about an interface with the listener and with the event source, this is how exactly is going to look. I am going to have first part or the upper layer, and I am going to have the below part or the second layer, which is going to make sure whatever the event has been generated will be processed and will be returned back with the appropriate result. Hence, we are going to have this setup. Now what happens? Now whenever there is an event occurrence, so a particular event listener should be accessed or should be activated or should be invoked in terms the event to be handled. Hence, whenever there is an event, any sort of event from the event source, an event object will be generated, and this event object now will be passed to the event listener, where now the event listener will receive this object and it start processing. This is what happens in the event listener interface when I'm going to talk with respect to the delegation model. Now, so the classes which we already have discussed in the previous session, and the reason why again I have put over here is for any event what you have taken, you have been defined with an event class, and when there is an event class, when there is an event, there should be appropriate event listener. And all this green tabs, whatever I have been put, these are classes, what we call as event classes, and all this is going to be the listeners, the listener interfaces. These are interfaces. Hence we are going to have classes at the top layer, we are going to have interfaces at the bottom layer. And now in this session, we will see how exactly we are going to have, or what methods we are going to have with the listener interfaces, and with few examples we will see how we are going to bring into the programming world through implementation. Fine. And so now when you talk about the listener interfaces, it's all about the methods what we need to look into, because interfaces is just an abstract class type which contains only methods of no body, and now you need to use this interfaces and start defining the body for those interfaces. That is what, when you talk about interfaces, we will just look into what list of methods each interface is going to contain. And so now if I talk about the first interface, action listener, this contains one specific methods which we need to look into, that is the action performed. That is what action has been performed from the input GUI, whether the key is pressed, whether the mouse button is pressed, whether the radio button is chosen, or a checkbox is checked out. We are going to have what action has been performed, and this will be the object of the class action event. that an object will be created, as I said, for every event, and that object of the action event class will be passed as a parameter for the method of the interface action listener. So similarly, we are going to have adjustment listener, which is going to have one method which is going to say adjustment value change. If I'm going to have a scroll bar, what is the value of the change it's going to happen? That is what the adjustment object will be created and will be passed for this interface. And if I talk about the component listener, it is going to have 4 methods to be incorporated and defined. That is the component resized, the component moved, component shown, and component hidden for any given container. And all these methods is going to accept this as an object, the object of the class component event. And if I am going to have container listener interface, it is going to have 2 methods. When I add a component or when I want to add a component, I have a method called as component add. When I want to remove, I am going to have a method called as component removed, which takes the object from the container event class. And focus listener, it is going to have these 2 methods, the focus gained and the focus lost. And if I'm going to have input listener or the item listener, we're going to have void item state change. So whenever the item is going to change its state, we're going to have this method to be incorporated, and the item event will be the object as the parameter for this. And the reason why I didn't pick up this is because when I say input listener, there is no specific input listener interface. There is an input event class, but there is no input listener. Even if there is an input listener, it doesn't have any specific method, because the input listener is divided into the key listener or mouse listener, further to mouse wheel listener, and so on. Hence, if I discuss about key listener, the mouse listener, the mouse wheel listener, it's indirectly I'm discussing about an input listener. Hence, I'm not talking about what method this input listener is going to contain. And next, if I talk about the key listener, I am going to have these 3 methods, that is the key pressed, key released, and key typed. Now, whenever you want to talk about the keyboard events, so you should be able to define and able to use these 3 methods. That is the key listener interface methods. At point, it's going to take the object from the class key event. And if I'm going to have mouse listener, it's going to have this 5 methods. All these 5 methods should be defined. That is the mouse clicked, mouse entered, mouse exited, mouse pressed, as well as mouse released. You need to define and you need to handle all these methods if you're talking about the mouse input. And when I'm going to have mouse listener, so I can have 2 more interfaces or 2 more listener interfaces. The first one is the mouse motion listener, and next is the mouse wheel listener. Whenever you're going to have mouse input, so you will be not only concentrating upon whether I'm going to click a button, release a button, or drag a button. When I want to move the mouse, if I want to capture the motion of the mouse, then I'm going to even have the interface mouse motion listener. Or if I want any input from the wheel of the mouse, I'll be using mouse wheel listener. Hence, if I'm going to have mouse motion listener, I'll be having these 2 methods. That is mouse dragged and mouse moved. Even these events also should be defined if you are inheriting even this, or if you are implementing the mouse motion listener. And the mouse wheel listener, if you are implementing, you're going to have one method, mouse wheel moved, and the object from the event class, mouse wheel event. And the next we are going to have the text listener, where I'm going to check out whether the text field text data has been changed or not. That is the one method which I'll be using. And if I'm going to have Windows listener, I'll be having this set of methods to be defined. That is whether window is activated, window is closed, when the window is closing, deactivated, de-iconified, iconified, and opened. the set of methods you need to define where we are going to have this window listener. And when I am going to have window listener, we are going to have one more interface for Windows focused listener. Hence we are going to have these two methods, window gain focus and window lost focus method. What you're going to do at that point. These are the few set of the interface which you need to understand before you start using the delegation model for implementation. Fine. Now at this point of time, you know the set of event classes from the previous session and set of interfaces for the event handling, and which is going to give me an appropriate interfaces where we are going to can implement the delegation model. Hence, the first step whenever you want to use delegation event model to handle an event, the first step is you need to implement the appropriate interface. That is, if you want the mouse, then you need to implement the mouse listener. If you want the keyboard, you need to implement the keyboard listener. Hence, the first step is you need to implement the appropriate interface. Once you are going to done this, you need to define the methods which is going to register and unregister a particular method from a given event. And this is not necessary because whenever you use an interface, so it will automatically be registered and unregistered, because all the methods we need to define and we need to handle. Hence, the very first step you need to keep in mind is you need to implement appropriate interface. And just try to remember these points whenever you start implementing the event handling methods. The first step is a source may generate several types of inputs. One source can generate several types of inputs. Now, for example, for simplicity, if I take a mouse can generate several types of events. The first input can be clicking a button. The second input can be press of a button, release of a button, movement of a button, holding a button and moving a button, which makes me drag operation. So all these are different types of events what a single source can generate. And for all this each event, a separate listener method should be registered. That is what we are going to implement all the methods. So an object may register to receive several types of events also. I can have a single object can register to receive all the types of events into my processing block. So must implement all the interface that are required to receive these events. So if I'm going to have any one, for example, if I'm going to use mouse, so using mouse, so where we are going to use the mouse, so using mouse, we will be able to give the mouse input or the radio button input or the checkbox input. Hence, you should be able to implement an appropriate interface to receive different types of events from the same resource. This is what you should remember before you are going to use the delegation event model. Now, as an example, let us take the two important event source, that is the mouse and the keyboard, and we will try to implement this and we'll see how this is going to work. So when I talk about handling the mouse events, whenever we want to use the mouse, just look at this. These are the few things what I need to look out for. Now, as an example, I want this following operations to be performed with my mouse. That is, when I want the following operation, the very first step, as I told, you need to implement the appropriate interface. And so now, if I want to have the following operation, for example, I want to show the current coordinate values of a mouse. Hence, I need to have mouse listener interface. So I'm going to enter the window. I'm going to exit the window. So when I enter the window, mouse entered text should be displayed. When I exit, mouse exit message to be displayed. Again, this is going to be the mouse listener. A button pressed, button released is going to be again the mouse listener. And the clicked is going to be mouse listener. The drag is going to be mouse motion listener. And these are the few listeners which I need to implement as an interface if I want such operation. Now, just look at this. What all this operation is? If you are not understood, just look at this video how exactly it is going to work. Now when the mouse is going to enter, the message is mouse entered, or when I leave the mouse out of window, this is going to be mouse exited. When I click, I am going to have mouse clicked, and the down is also displayed, and when I release, up will be displayed. And you can just see here, so it is going to show a message moving mouse, that is at the following coordinate system, or when I drag the mouse, a message will be displayed as dragging mouse. And so we are going to release mouse, we are going to get the up method, and when the mouse is out of focus, we are going to have mouse exited. So the few operations which I need to perform whenever I am going to have a mouse event. Now we'll see how exactly this we are going to implement. Fine. So now when I'm going to have this particular mouse event to be read or processed, the first thing is you should be able to create a applet program. Fine. At abstract, let me introduce you the applet program, the basic applet program. So in the next sessions, I'll be making you to work on the actual applet program. But right now, as an example, just look at this applet program. So now we are going to, whenever I want to make use of any of an event through GUI, I need to have an applet, and for this case, I am going to import all these packages. That is the AWT or AWT.event, which is going to give me the event classes, which is going to give me the interfaces. And when I want this GUI window to be created, I am going to have the applet. I am going to use the applet package. And when you're going to have an applet, so you can execute an applet program in two ways. The first way is creating a Java program and compiling this to be error free and executing an applet program using an HTML browser. Or the second way is you're going to compile this program using a Java compiler, and using a applet viewer tool, you're going to execute from the console. But the easiest way is executing an applet program using a HTML browser. Compile this at the terminal, and you're going to execute this at a browser. But right now, when I am going to do applet program, usually I'm going to use an IDE. I'll be using a NetBeans IDE whenever I want to create and execute an applet program. But if you want an easier way of doing this without making use of IDE from the terminal, you have got the two ways to do that. Fine. And so now this example program, whatever I have input over here, this is the example where this program should be executed from an HTML browser. Hence, if it wants to be executed, so you can observe we are using a HTML tag over here. The HTML tag opens the tag with the name applet tag, and this is the close of a applet tag. So in this tag, I am giving what is the window name is going to be. The window name is going to be along with the size of the window, that is 300 width, and height is going to be 100. So now this is the initial setup what you should make. So install these packages and make sure you are going to have a HTML tag so that this can be executed using a HTML browser. So now if I am going to have a class now, so now the class is going to be a mouse events, now which is going to extend the applet. Because the class now what I am going to create is going to be a GUI application, hence it needs to inherit the class applet, as the applet becomes the super class and the my class becomes the derived class which derives the property to act as an GUI application. And now I want the mouse events to be handled, hence I'll be implementing the two listeners, the mouse listener and the mouse motion listener. I don't need the mouse wheel listener over here, motion wheel listener over here, because I'm not working with the wheel of the mouse as an input right now. Hence I just want only these two listeners. Hence I'm going to have a class now which uses the class applet class and implements these two interfaces. And now all the methods of these two interfaces should be defined. Remember this. All the methods, whatever have been listed a few slides back, should be implemented now. All those methods. Hence, Now I need to display such messages called as mouse clicked or mouse entry, mouse exit, or moving mouse and so on. So to display this, I am going to have a string called as message. Right now at the initially it's going to be an empty string. And I should know what is the mouse value is going to print the mouse value over here. I need to know what is the mouse X value and the mouse Y value. Hence I'll be storing the position of the current mouse position using these two variables. And I need to initialize this. I need to initialize this. Hence I'm going to call the init function, and I'm just going to say add mouse listener, the interface. I'm going to pass the current object which is holding the reference of a current event. Hence I'm passing this as a parameter. So similarly I'm going to add the mouse motion listener. Hence I'm going to register now. I'm registering the mouse listener. I'm registering the mouse motion listener. If you remember, so the second step. The first step is you need to implement the listeners, appropriate listener. The second step is you need to register the listeners. This is what I'm doing here. And once this is done, whatever now I want to draw on this window, whatever the window I have been created on this window, if I should be able to put any content on this, it should go to the function called as paint, and which is going to be a graphics input as an object. And now I'm going to call g.drawString. Now whatever the parameter I pass for this will be displayed on this applet window. And so now the message what I want to display, and I'm going to display at what point this message should be displayed. Now this is going to be x is 0, x will be 0, and y is going to be, if y is also 0, I'll be displaying the message over here, but I'm putting it down. And the y value should be something different or some higher value than 0, something like 10 or 15 or 20, so on, to display the message at this point. That is what this method is going to do. Whenever I want to put anything on the applet window, it should go through the paint method only. Hence, we're going to use these two methods right now. So now I want to display the current coordinate as the status. This is the status window or the window status. This is where I need to print the current coordinate value. Hence, to do that, I'm going to have a method called as mouse entered. That is, now whenever I'm going to have the mouse entered event, now I'm going to call this function. When the mouse is going to be in this area, we call this as enter. When the mouse moves away from this window, we call this as exit. Hence, we are going to have mouse entered event. So just going to be in the mouse listener, which takes the object of mouse event. X value is 0, Y value is 10, and this is 0, 10. And the message is mouse entered. The mouse entered message will be displayed over here. And when I say repaint, the paint function will be called. Whenever I'm going to say repaint, the paint function will be called. Now the updated message or the updated mouse X, mouse value will be used on this window. It's what mouse entered is going to work with. And when I'm going to say mouse exited, again the same object at the same position. Now the message is mouse exited. I'm going to redraw or I'm going to repaint. And this is going to be mouse exited. And the next function what I want is mouse pressed. So when I press, I should display a message called as down. Hence I'm going to have the message as down. And when I press the down button, I should know what is the X value and the Y value of the current pointer where I am using. Hence I'm going to use the function getX and use the function getY from the object of the mouse event ME. Hence I'm going to store this value as MX, store this value as MY, and use this location mouse X and mouse Y to print the message down. Hence now wherever you click the mouse button, at the top of this arrow or the pointer, the down message will be displayed, because I'm storing the current X value and the current value wherever I have been pressed the mouse button. This is what the use of this method is going to be. And next, if I am going to have mouse released, that is, I have pressed the button, I am going to display the down message. When I release the button, the same way, but I'll be printing or displaying the message called as hub. This is how we're going to make use of all these methods. And when I'm going to have mouse clicked, so press and release are different than the click. The click is I'm just going to press and release at a time. That is what we call this as mouse click. Again, I'm going to have 0, 10. At this position, at the top position, I'm going to print the message as mouse clicked and recall the repaint. When I drag the mouse, again I need the X and Y value. I'm going to use the message as star, and I'm going to print some message over here, that is show status. When I'm going to use the method show status, this is the status bar of your window. This status bar will be used to print the message. If I'm going to call the paint and say drawstring, you can print the message wherever you want. If you want the message on this status bar, I'm going to use the method show status. And in this, I'm going to print the message as dragging mouse at, I'm going to print the position of X, comma position of Y, and I'm going to repaint it. And the mouse which we are going to move, if I'm going to keep on moving the mouse, the value should be keep on changing here. And that is what moving mouse message what I'm displaying at the status bar. So now I don't want the value of X and Y. I just want only where I'm moving. Hence I'm going to print the message as my get Y and my get X value over this. This is how all the methods. Now 1, 2, 3, 4 and 5. All these 5 methods are of the interface mouse listener which we have been implemented. And these are the 2 methods of mouse motion listener which also we have been implemented. Hence you are going to get such output if you are done with this program. And this is how we are going to bring in the interface and the event objects, where this interface will receive the event objects, and receiving the event object will be processed the way it wants, or we can make this to work the way we want. And this is how we are going to make use of the mouse event in your program. And one more important event source as an example is how we are going to handle the keyboard events. This is again similar to the mouse events. And just look at this. Now in this we have got 3 main events. The key is pressed, the key is released, and the key is typed. We are going to have 3 types. Now just observe this video, what exactly we are doing here. When I press a key, on this keyboard, you can see key is down, and I am going to release the key. We are going to have key up. When I am going to press any character on the keyboard, you can see the typing is going to flow here. The typing of the character what I am going to have is going to be typed. Hence the 3 events, the key up, key down, and key type. This is what we need to have in this event listener. Hence now if I want to implement this, this is the function what I am going to have. So the same package which we are going to import, and this is what we should do with the HTML tag, and the class name is simple key, which extends the applet as usual and implements one interface called as key listener. And this key listener should be registered, and so I'm going to register the add key listener in your system. And I should know what is the X value 10 and Y value 20. So this is the position where the typing is going to happen. And the message, right now it's empty string. And the key pressed method, key released method, and the key typed method. And the paint as usual what I've been explaining in the previous program. And now I'm going to type whatever value I'm going to have. I'm going to type it as X equals 10 and Y equals 20 at this position. As the character will be typed, the value of X and Y will be auto incremented. And so I'm going to have keep. When the key press, the status bar will show up as key down, and when I release, it's going to show key up. This is where I'm going to print the status message. And when I'm going to start typing something, this method will be called with the object. So I'm going to say what key character has been typed. I'm going to put into the message. So message will be keep on adding character by character. It's going to be keep on adding character by character. And at the position of X comma Y, I'll be keep on printing the string. That is what I'm going to print the message. So if you have understood the previous program, this program becomes an easier program rather than that. This is how the key program is going to work. But one more important thing what you want to note here is, when I press some key, there are keys which you can display. That's something like I'm just going to have a key. If I press D, I'll be having D as a character on the screen. If I press E, so such characters can be displayed. But what if I'm going to press the Alt key? It's not displayed. What if I'm going to press the Alt key, Control key, or the up key, the down key, right arrow, left arrow, F1 functions keys? Now these keys are not displayed. And so now if I want to display this, what exactly I'm working, you need to update the key pressed function. In the key press function, because this cannot be done in the key type. So this should be done in the key pressed, and I need to know what is the code of the key what I have been pressed. Rather than knowing what character has been pressed, I should know what code has been pressed when the keyboard has been used. Hence, I am going to get the key code, and with the switch statement with the appropriate key code, if it's virtual key F1, so print the message as F1. So I am going to break the case statement. And if it is virtual key F2, print it as F2. If it is page down, print it as page down. Hence, so using key code, I can process the way I want, and I'm going to repaint this. This is what is going to happen in the handling the keyboard events. These are two important examples which you need to understand. And this is how we are going to implement the delegation model to generate an event and pass that event object to the event listener, and how exactly the event listener will make use of this object whenever it wants to handle or process the given event or the generated event. And with this, there's some sort of improvisation what we can make for this implementation. So these are not strictly to be followed, but you should know about this at the abstract level so that you can think about improvisation. Now just remember, when I was saying that if we are going to implement any interface, all the methods of the interface should be defined. If the interface contains 7 methods, all the 7 methods, you may need it or not. For example, I don't want to work with the mouse click. I just want only the mouse press and mouse release. But if you want to have this, you'll be including the mouse listener. So the mouse listener has got all the 5 methods. All these 5 methods should be implemented. Even though you don't want the mouse clicked event to occur or to be handled, still you should be implement either a empty body method or whatever you want, but you should be implemented. But now I should not be so strictly with these functions. I want some lenience in this. That is where the adapter class will come into picture. So whenever you think about implementing only those events in which you are interested in, so think about adapter class. Hence we are going to have component adapter, the container adapter, the focus, the key, the mouse motion, window adapter, whatever the class we add. Almost for all those classes we are going to have adapter classes. Instead of using component event class, I will be using component adapter class. Instead of using mouse event class, now I can make use of mouse adapter class. If you are going to have mouse event class object and its interface, all the interface methods should be implemented. But if I use mouse adapter, only the method which you are interested right now to do with, only you can think about that. And that is what this example is going to do. Now I just want only the 2 methods to have. I just want to have the mouse dragged feature from the motion adapter, and I just want the mouse clicked from the mouse listener. Hence I am just using only 2 methods. I am not defining all the methods over here. Hence I am going to have public class adapter demo as the class name, which extends applet. Right now I am not implementing any interface, but I am going to register. I am registering the mouse listener. I am registering the mouse motion listener. But when I am registering, just observe here, I am not registering the current object itself or the current listener for the event. I am creating the object for the class what I am having my mouse adapter and my mouse adapter. So the objects which I am using to register right now. Hence now whatever the event generated from the mouse listener or from the motion mouse listener will be passed on to these two classes with respect to what event you have been generated. Hence in this class I am going to have the object of the adapter demo where I am going to create the object and I need to pass the object as a parameter to this operator, and I'm going to store it in this data member and use this data member object whenever you want to print some message on the window. So similarly I'm going to do the same way here. So in this program we are going to register the listener and the motion listener of the mouse using my own classes, and this class should be able to receive the event through the data member reference what I am creating for this class, which is going to be an applet. And so now this is going to be how we are going to make use of adapter class. So now this adapter class, whatever you have seen, so this can be further improvised to remove some sort of confusion by bringing the inner class method. So before looking at the inner class method, just look at this non-inner class example. So rather than having separate methods, I'll be having the same method, same class, where every method I'm going to put in the same class. Now for example, I'm going to have public class. So mouse press demo, which is going to be an applet. I am going to register the mouse listener and it's going to have its own. I'm going to have its own method. So I'm declaring my mouse adapter method, and in this I'm going to call the function by passing a parameter and the mouse pressed event. The same example what we have looked. So this is an example where we are not using the concept of inner class, and this is going to give some sort of problem or some sort of complexity how exactly is going to handle, because I'm creating a class here and I'm calling the class method over here by passing the parameter as the object of this class, and inside this class I am using a reference of this class and I'm storing. This is some sort of confusion is going to happen, or even the maintenance is going to happen in difficult. Hence for that case, so this same program has been improvised using an inner class. Now using this inner class, just look at the simplicity what we have made here. So now I'm going to have initialize, where I'm going to initialize an adapter or a mouse listener by using the class what I have been defined. And if you observe, so instead of putting this class outside, I made this as nested class. This is what we call this as inner class. Now I need not create the reference of this, and I need not initialize that reference variable with the object of my mouse adapter. Just use this as an object over here and make use of the method mouse pressed whenever I want to print something on the display device. This is what the inner class is going to enhance the programming skill of your program. And the next improvisation what I can make is, so instead of giving an class name, now even I can remove the class name what I wanted, or the class name whatever I had given here. That is, the class name I had given this as my mouse adapter. So now even I can avoid using the mouse adapter class name. Just I can make use of anonymous inner class. Without the name, your program will take up the event, pass the event, and just the event and so on. Hence if you just look at this examples, now in this example program, to just remove your confusion, so now whenever we are going to have an mouse event, rather than implementing all the mouse event interface methods, I want to implement only the methods which I'm interested in. This is the first point what I made. And right now, just concentrate on this particular block. I want only this mouse click to be implemented, and so I'm using mouse adapter. So now in this case, this improvisation I'm going to make using an inner class. So now this is a non-inner class, which is the same program what I had over here. I have just removed this block now. I'm using only these two blocks, and I'm just going to have this as a block where I'm going to have an class and I'm going to have second class. So I'm going to have two different classes which doesn't relate each other. Hence for that I should have created an object of this class inside this class, and the reference of this class should have been made inside this class. So instead of having this certain complexity, we are going to bring in the concept of inner class, where the class which was outside this main class, we are going to bring this inside the class itself. Hence by doing this, I need not store the reference and need not pass the reference. And further, still I can ask this by removing the class name as my mouse adapter itself, by using the concept of anonymous inner class. This is what the simplicity what I'm going to make. So we'll just keep on enhancing the code. This is what you need to understand in this session, and thank you for this session.